Hello, my name is Chanel LoJacono, and the title of my presentation today is A Dynamic Virtual Reality Obstacle Course May Improve Balance, Preliminary Data. Falling is a major public health concern for older adults age 65 and older. Falling leads to a significant risk of injury for older adults, and these injuries typically lead to decreases in physical capacity and increased fear of falling, therefore overall decreasing quality of life. There are many risk factors for falling. However, one of the major factors is a decrement in balance. Now, there have been some fall prevention programs that have been designed to improve fall risk factors, but typically these programs can be costly and require resources of both human and physical nature, which may be unavailable in some clinical settings. Now, virtual reality may provide a solution to these barriers. Virtual reality is both cost effective, as most systems may be bought off the shelf at a local store, and resource efficient, as there are not any physical objects utilized in the virtual environment. Some previous research has been conducted that has utilized training with virtual reality components. More specifically, virtual reality obstacle crossing training has shown some success in improving fall risk factors of gait and balance. However, these studies have been limited to non-immersive virtual reality training on a treadmill. A treadmill constrains movement to mainly two dimensions, whereas in our everyday lives, we must navigate our environment and navigate obstacles in all three dimensions. Therefore, it's unknown whether or not an immersive virtual reality obstacle course that is actually over ground may improve fall risk factors, and specifically in this study, balance. The purpose of this study was to determine the extent to which balance may be improved via an overground virtual reality obstacle course environment. And our hypothesis was that the virtual reality training group would show improvements in postural control compared to controls. For our methods, we recruited 26 healthy young adults. This study utilized a pre-post test design in which the B-Trax balance test was completed at both time points. The B-Trax balance test consists of an individual stepping onto a portable force plate with their feet shoulder width apart, hands on hips facing forward. They are asked to close their eyes for 20 seconds for 3 different trials. After completing the pre-test and the B-Trax balance test, participants were placed into either the training group or the control group. The training group completed 15 trials of an immersive virtual reality obstacle course with 30 seconds of rest in between. The virtual environment was implemented using a head-mounted display, the HTC Vive Pro, as seen here, and associated foot trackers were placed on the feet to give real-time feedback of foot position within the virtual reality, more specifically with the virtual sneakers. The virtual reality obstacle course included both yellow obstacles and blue obstacles. The yellow obstacles were designed to be avoided, and the blue obstacles were designed to be stepped on. If a yellow obstacle was contacted when it was not supposed to, it turned red and played a negative auditory tone. When a blue obstacle was contacted that was supposed to be contacted, it turned green and a positive click sound was heard. So they received feedback of performance within the environment. The control group, on the other hand, walked over ground for 15 minutes consecutively to control for physical activity duration. From the B-Trax balance test that we implemented in both pre and post testing, we were able to calculate error score and sample entropy of the resultant velocity of center of pressure. The error score is a measurement of the average path length of the center of pressure across all 3 trials. A decrease in error score is going to indicate a decrease in postural sway and therefore improved postural control. Sample entropy, on the other hand, is a measure of complexity, and it allows us to have some more information about adaptability. And in this study, an increase in sample entropy of the center of pressure velocity indicates an increase in complexity and therefore improved postural control. For our results, first looking at error score, the training group showed a decrease from pre to post test and a small effect size of 0.23. The control group, however, did not show a difference really in pre to post testing, and essentially no effect size was observed there. For sample entropy, while the training group had a larger effect size than the control group, neither group met the threshold for an effect, and the changes from pre to post were relatively minimal. For our discussion here, we can kind of say, based on our results, that decreases in error score as seen in our training group are associated with some improvements in postural control and therefore balance. However, our expected increases in sample entropy were not observed for the training group. This may be because the virtual environment was maybe not challenging enough. The obstacles maybe there weren't enough or they weren't high enough. And also maybe this task is not long enough in duration to produce changes in the underlying structure and complexity of postural control. To conclude, a virtual reality obstacle course environment may be effective in improving balance compared to active control group. However, there's much more research that's needed to determine the effects of a more long-term and perhaps more challenging intervention on changes in variability of postural control. Thank you very much.